Yeah, Kings Island is rain or shine. You're going.
Yay.
Last year was nice. Last year was kind of chilly. The high was in the upper 50s, but it was sunshine. And I think because we went on a Monday, that was the first time we got to choose to go on a Monday, there's nobody there.
It was nice.
Yeah, I like that.
What day are we going this time? Friday?
It's a Friday, but hopefully it's the first Friday of the season. Maybe some of the other classes will go later. We couldn't go later because of our schedule, because we're out so early.
We should have went on the 19th. You just skip graduation.
Have graduation at Kings Island.
Yeah.
Have it in the amphitheater.
Here's square root of x. Here's the line y equals 2. And x equals 0 is the y-axis. So we're talking about this region, correct?
Yes.
Now, I want to revolve about this line. So not an axis, I want to revolve about this line. Everyone see that?
Yeah.
So when I do that, I can't write from the side. It looks something like that.
Somewhat. Yes.
It's going to look kind of like a cone, but with curvy sides, right? Or like a funnel, maybe.
A mountain.
You would use them.
A sideways mountain.
You know, like a funnel, you know, they're curved. Yeah. Okay. Anyway, so do I have a hole?
No.
No. So it's just the integral of the area. So once again, my area, they're circles. So it would be pi. Now here's where we have to really think. The radius can either be drawn from here to here or here to here, correct? Does everyone see those? Now, I personally would use this one, but you can use that one. I think it's a little tougher, though. Much tougher. Because I need to realize that this distance right here is square root of x, right? Square root of x, square root of x, square root of x. But I want this. 2 take out the square root of x. Correct. So I have 2 minus the square root of x. Now, had you tried to use this, it's been way more complicated. You would have had to do some reflections, and it's not fun. It's not fun. Okay? But, does everyone see that? Because this distance is 2, but I want to take out this because I want the leftovers. Sometimes you're subtracting. Sometimes you're adding. There is no shortcut of saying, I'm always going to subtract when it's this case. I'm always going to subtract when it's this case. Everyone wants to do that. They want to come up with, oh, it's always this when this happens. No, it is not always anything. It all depends on your graph. That's what it comes down to. So, what I do is going to pull the pi out. 2 minus square root of x squared. Now I need to figure out my bounds. Well, the first bound is obvious, 0. Correct?
Yeah.
Now think about right here. You have the equation y equals square root of x, but you also know y is 2. So what did x have to be? 4. Let's multiply that out. It's 2 minus square root of x, 2 minus square root of x, dx. So I will get 4 minus square root of x minus square root of x, which is really minus 2 square root of x.
Wait. I thought it should be minus 4 squared.
2. Okay, thank you. That's good. And then plus x dx.
Yep.
You with me there? Okay, so my antiderivative is 4x minus, now think about this one over here, that is 4x to the 1/2. Add 1, you get 3 halves, right? 4 divided by 3 halves is 4 times 2 thirds. 8 thirds x to the 3 halves, plus 1/2 x squared. Okay, let's plug in 4. Here I'll get 16. What will I get here?
64 thirds.
2 minus 64 all over 3. This is all times 5, by the way. Which will give me 8 pi over 3. Questions? Let's try another.